Hello and welcome to Honors Function. So after introducing the motivation for complex number, let's start looking at them. A complex number is a number that I can write a plus ib. A and b are both real number. I is such that I squared equals -1. I is a number such that I squared equals -1. So of course I is not in R. Okay, I is not in R. A and B, they have a name. A is called the real part of the complex number. So usually we write the letter Z for complex number. A is called the real part of Z, and B is called the imaginary part of Z. And these two functions, you have them in your calculator. I'll show you where to find them, okay? So just as we often use X for real number, we often use Z for complex number. So this is the notation for a real number. How do we denote the set of complex number? Where we would say that Z is an element of C, the set of complex number, okay? Lastly, the last definition is that we say that a complex number Z is equal to 0 if and only if its real part is equal to 0 and its imaginary part is also equal to 0. Okay, so we're going to take this as a definition. Let's go over some examples. So here are some examples of complex number. Here's the first one. What is the real part of Z? The real part of 8 minus 3i is 8. And the imaginary part of 8 minus 3i is the coefficient of I, which is -3. Never write I in the imaginary part, okay? The real part of a complex number and the imaginary part of a complex number are both real. Okay, do not write I in the imaginary part. Okay, I did one, you do two. Let me do number 3. What is the real part of -4? Well, I can write -4 as -4 plus 0 times I, right? This is written as A plus IB. IB, BI, same thing. So the real part of -4 is -4, and the imaginary part of -4 is 0. Okay, and this is why this is the first point of my remark below. This is why a real number, if you take any real number, it's also a complex number, right? -4 is a real number, but it's also a complex number. So the set of real number is included in the set of complex number. If you are real, you are complex. But of course, there are many complex numbers that are not real, okay? So this is the first point of the remark below. I'm gonna let you do example 4, and I'm going to cover the other 3 or 4 points of the remark, okay? All right, so that's the first one. The second one, the form A plus IB is called the rectangular form of a complex number, rectangular or standard. Okay, we call that the standard form. Well, that means there are other forms, and we will look at them much later in the year. Okay. Then the other remark, another remark is that a complex number, you know a complex number completely if you know its real part and you know its imaginary part, because a complex number is always this. Okay, that's it. This is a complex number. This is equal to Z. So if you know the real part and the imaginary part, you know the entire complex number. And then two important remark. Another one is, if you are given two complex number, you cannot compare them. What does it mean? That means you cannot say if Z1 is above Z2 or Z2 above Z1. Okay, you cannot say that. Or another way of saying that, if you are given a complex number, you cannot decide if it's positive or if it's negative. Okay, you can't. Except except if the complex number happens to be real. Okay, then yes, here I can tell you which one is, if it's positive or negative, or if I have two complex numbers that are both real, I can compare them. But in general, there is no order relation. There is no order relation in C. Okay, we do not have an order relation in C. Finally, a complex number, two complex numbers will be equal to each other if and only if the real part of Z1 is equal to the real part of Z2, and the imaginary part of Z1 is equal to the imaginary part of Z2. Okay, and this comes from the definition of Z equals 0 if and only if the real part of Z equals the imaginary part of Z is equal to 0. Okay, this implies this. All right, you can prove it if you want. It's very simple. I'm not going to do that. Let's now do some algebra with complex number. Algebra means I want to combine them. So let's define two algebraic operation. Okay, so I'm given two complex number and I'm going to define two ways to combine them. The first way is the addition, and for that we use the same symbol that we use for any other numbers, this cross like that. Okay, how do we add them? Well, this is very easy. You add the real parts together and then you add the imaginary parts together. Okay, so this is just a1 plus a2 plus I times b1 plus b2. It's like factoring I. That's it. And this is a definition. All right. The second operation I'm going to define is the multiplication of complex number. How do you define that? So check it out. It's very simple. a1 a2 minus b1 b2 plus I times a1 b2 plus a2 b1. Simple, right? Not. Of course you don't have to remember this formula. You see that and you're like, what? What is this? You don't have to remember the formula to multiply two complex number. What you do is very simple. You just distribute everything. Check it out. Here's a1 plus ib1 and a2 plus ib2. I'm just going to distribute this as if I was dealing with polynomial, and instead of I had x. Same deal. Okay, so let's distribute. You got a1 a2 plus a1 times ib2 plus ib1 times a2 plus ib1 times ib2. Okay, I think I have everything. Yes, so what's going on here? First of all, the multiplication is associative right here. Okay, so a1 times I times ib2, this is just I times a1 b2 plus I'm not touching this one, I times b1 a2. Okay, got it. Then here we go. Then what is this? This is I times b1 times b2. I times I is I squared, and I squared is negative 1 by definition. So this is negative b1 b2, and this is a1 a2. And you see these two right here is the real part, and if you factor I, it's I times I'm sorry, not here, I meant right here, the real part. And when you factor I right here, you would get I times a1 b2 plus a2 b1. Okay, so it is actually very, very simple. You've known how to FOIL for a long time now. Let's go over some examples. All right, example 5. Let's add and multiply these two complex numbers. So 8 minus 3i plus negative 5 plus I. Now, I really shouldn't write two signs like that next to each other. I know you all do that, or many of you do that, but this is not correct, okay? So, and here, let's put the first one in parentheses too. Why not? So this is what? 8 minus 5, 3. And then negative 3i plus I, negative 2i. That's it, okay? Very, very simple. Let's now multiply them. 8 minus 3i Now I have to put the parenthesis times negative 5 plus I. So I have negative 40, and let me grab the other real part. So I have right here negative 3i squared. Negative 3i squared is plus 3, right? I squared is negative 1, so it's plus 3. Got it? And then plus I times what? How many i's? Well, you got negative 3 times negative 5, 15. Okay, got it. And then plus 8. That's it. Very, very straightforward. Negative 37 plus 23i. Okay, all right. I'll let you do number 6. Let's move to the next example. Number 7. So what's going on here? Suppose you have a complex number a plus ib whose square is equal to I. I want you to find the standard form of z. Oh, all right. Let's see what's going on. Let me square a plus ib. Let me just square it. So I need to do a plus ib times a plus ib. I'm not sure if my formula here, which I've been stressing a lot, will work. Okay, so I want to take my time and make sure it works fine. So this is a squared, and then my the other part of the real part is right here. So this is minus b squared. Okay, got that. Let me now grab my imaginary part plus I times what? AB, and then plus AB, right? So it is 2AB. Okay, I think my formula would have worked fine. So I want this to be equal to what? To I. I want this to be equal to I. I is 0 plus I. So this is an equality of two complex number. Therefore, if two complex numbers are equal, according to the remark above, their real part and the imaginary part must be equal. So I must have a squared minus b squared equals 0, and at the same time I must have 2ab equals, here it's 1, right? The imaginary part equals 1. Okay, I see. I think I understand what's going on here. What's the first thing right here? A squared minus b squared equals 0. Well, that means that a is equal to plus or minus b. Okay, and the second one, it means that it means that ab is equal to 1. All right. So there are two things we have to be careful of right here. If two possibilities, right? So if a equals b. If a equals b, what do you... I forgot to divide by 2 right here, I'm sorry. If a equals b, what do you have? You have a squared equals 1/2, a squared equals 1/2. So a equals b equals plus or minus 1 over root 2, right? And in the other possibility is if a is the opposite of b. So we have negative, if a is the opposite of b right here, it's a times negative a, right? So we have negative a squared equals 1/2, which this has no meaning because that means that a squared equals negative 1/2. And don't forget that a is a real number, right? A is a real number, so this has no meaning. All right, so we have these two cases. So we have right here the two solutions to the equation. Let's call the first one z1 and the second one z2. z1 is 1 over root 2 plus I times 1 over root 2. This is when I take a equals b equals 1 over root 2. And the second one is negative 1 over root 2 minus I times negative 1 over root 2. Okay? These two complex numbers are solution of the equation z squared equals I. Okay? Let me also tell you something else. The one with the positive real part, we have a notation for this one. It's called the square root of I. The square root of I is z1, the one that has a positive real part. We're going to need that in, I think, notes 32. Okay, so this one is called the principal square root of I. Okay, the principal square root of I. And the other one is not called the principal square root of I. That's it. That's all. All right. So this one was a little bit more complex. I'm going to let you do the next example, which is example number 8. Let's move to a definition. If you are given a complex number z, we call the conjugate of z the complex number a minus ib. Okay, you change the sign of the imaginary part, only the imaginary part, and there is a notation for the conjugate of z. It's written z with a bar on top. Okay, z conjugate, so you read that as z conjugate, or sometimes some students, and I have to say me too, will read it as z bar. I don't know, it sounds good. Z bar makes me think of Zanzibar. Anyway, let's move on. So here's a complex number, z equals 8 minus 3i, and z bar is going to be 8 plus 3i, and I want to find z times z bar. Z bar. So what is this? This is 8 minus 3i times 8 plus 3i. Okay, hey, the formula do work, so let's apply the formula. This is a minus b times a plus b, or I should say x minus y times x plus y. X minus y times x plus y is x squared minus y squared. Okay, now this is gonna be 64, but here you have minus, and 3i squared is 9i squared, and I squared is negative 1. So it's actually 64 plus 9, which is 73. Okay, so this is actually a formula that works all the time, and you need to know it. You need to know it. If you multiply z by z bar, and if z is a plus ib, you will always find a squared plus b squared. So not only the product of z times z bar is a real number, but it's also a positive or non-negative real number. Okay, not only it's a real number, but it's also always non-negative. That's very, very interesting. And this is the next proposition. Okay, let's go to the last operation of complex number. And the last operation of complex number is the division of complex number. So we're going to define this as a multiplication of a complex number with its reciprocal. Okay, therefore I need to define the reciprocal of a complex number. So let's do that. So what is the reciprocal of a complex number? Well, by definition, it's just 1 over a plus ib, right? If z is a plus ib, let's say z is a plus ib. And that's okay, but that's not the standard form. That's not the standard form. So can we get the standard form? And how? Yes, we can, and that's super easy. You take 1 over z and you multiply both sides by z bar. That's it, z bar. Why? What is z times z bar? It's a squared plus b squared. So it's z bar over a squared plus b squared. That's it. It's that simple. So let's go over one example. Here we go. I'm given two complex numbers and I want to divide them. So I know what I need to do. I need to do z1 times 1 over z2. And so now let's take a look at 1 over z2. 1 over z2 is 1 over negative 5 plus I. And this is a fine complex number, right? This is a complex number. It's just not written in standard form. So let's write it in standard form. I'm going to multiply both sides of this fraction by the conjugate of negative 5 plus I, which is negative 5 minus I, okay, times negative 5 minus I. I have a formula for that, a squared plus b squared. So this is just 25, and b is negative 1, right? So b squared is 1, that's it, negative 5 minus I. So what is it? It's negative, this is 26 right here, right? 26. So it's negative 5 over 26 minus I over 26. And so now if you want to finish the division, you do 8 minus 3i times negative 5 over 26 minus I times 1 over 26. And then you just FOIL this. So I'm not going to do that because this is a little bit messy. and I'm going to let you also do number 12, which is the last problem. Actually, let me do one in number 12. You have to do a couple, okay? Actually, there are two problems here, all right? So let me do one of them. What's the real part of 2 minus I over 1 plus 2i? Well, I'm not sure, but 2 minus I over 1 plus 2i, if I want the real part, I better write it in standard form, right? So it's 2 minus I over 1 plus 2i. How do you write that in standard form? You multiply both sides by 1 minus 2i, right here. 1 minus 2i, okay. So what is this now? This is, so I know what I have at the denominator, a squared plus b squared, 1 plus 4, a squared plus b squared. And at the numerator I have 2 minus 4i minus I, and then here it's plus 2i squared, so minus 2 right here, right? Plus the 2 minus make a plus, and I have 2i squared, so it's minus 2. So what is this? The 2 minus 2 will cancel. It's negative 5i over 5, so this is negative I. And so the real part of z minus I, sorry, therefore, the real part of 2 minus I over 1 plus 2i is 0, while the imaginary part, right, this is 0 minus I, while the imaginary part of 2 minus I over 1 plus 2i is negative 1. Alright, I'm gonna cut this video right here. It's over 20 minutes, but it's actually pretty simple, everything that is in it, so I don't foresee any difficulty there. Thank you for watching.